Today, it's going to be my pleasure to talk to you about the realm of possibilities with DBT. So first, before I start, we were introduced, but I just want to reintroduce us. My name is Nasko. I'm a solution architect at senior solution architect at Infostrux. And with me today is Nadji, who is also a senior solution architect at Infostrux.
Everyone.
Now today, I've split up this talk into three parts, which I think are just normal questions to ask when you're looking at a new tool to do a significant job, which is, first, what's the context in which the tool operates and what's like using it? Do you like it? And what are the trade-offs, right? Because every tool has trade-offs. So if we go right into it, what exactly is DBT? So as they like to say in their motto, DBT puts the T as in transform in ETL, right? But what you need to know is that it's a very small command line application that is written in Python, and you specify your models in SQL, vanilla SQL language, which is augmented with a little bit of Jinja 2 templating. And what it will basically do is send commands to your data warehouse to perform transformations. And it itself has a very minimal folder structure, and the use of SQL gives it a very concise syntax. But more importantly, because it's a command line application written in Python, you can run it almost anywhere, right? Now, because DBT can give transformations a more broad appeal than just to the typical big data engineer, I would just like to start with giving a broad explanation of what ETL actually is, right? So ETL stands for extract, transform, and load. Extract meaning that you're getting data from different sources. Transform meaning that you manipulate that data to make it fit into, make it look how you want it to look. And then load as in you store it in a data warehouse of your choice. So if I give you a typical example, if you have a user visiting your website, well, you might want to track him on the website. You might want to know which customer support messages he's given you. And you might want to know which newsletters he received that you sent through like SendGrid, for example, right? But this poses a problem when you're trying to merge all that, which is that, a user can have a different name in all these tools, and variables can have different names, can be written differently. And the data that's contained can be inconsistent across tools, but even inside of tools, right? So you can imagine that, this probably won't happen with a very big SaaS tool where probably there will be very homogeneous, but if you've built an internal tool, you might have Canada written in 4 ways, right? So that's the broad thing. So you would put the transformation part into 2 broad categories. The first one being data cleaning, which is where ensuring that you have this high quality, consistent data across all the tools. And then data modeling, which is where you're trying to make your data useful by representing it in logical concepts that are consistent across the different sources. Now, if you look at the transformation landscape today, you can kind of put it into 2 categories, right? On one side, you have SQL-based tools, and the other side, you have, tools that expect you to use a programming language such as Python, JavaScript, etc., right? And to be perfectly transparent, I personally fall in the category of preferring to use Python traditionally. That's my comfort zone by far. But if you're using DBT or tools that I would typically use, what does this look like? Well, with DBT, you have to learn vanilla SQL, and you have to learn a bit of Jinja 2 templating, which is also optional. Whereas if I were to do this in Python, as I've done for many years, I would get to use Python, which is a very nice language, but I'd have to use a variety of libraries and tools that are all evolving separately and are not always compatible with every version of Python, and they have quite the learning curve, right? But if I were to do that, what did it typically look like? So it would typically look like me extracting data from these sources and storing it in a bucket or some sort of storage mechanism, and then downloading this data onto a cluster, typically a cluster of compute nodes, where I would actually copy the data onto them and perform transformations myself that I'd have to write myself using Python Pandas or Dask. And right away, you know, I have to manage this infrastructure, and I have to make sure that I'm not going above the load capacity of the infrastructure. And if it's taking too long or something, I need to make sure that I can parallelize all this nicely so that it happens in a reasonable amount of time. And once all that hard work is done, then I put the data into a data warehouse.